Nvidia founder and CEO, Jensen Huang.
Hello, Mumbai! Wow, it's so great to be here. India, very, very dear to the world's computer industry, central to the IT industry, at the center, at the core of the IT of just about every single company in the world. Let me thank all of our partners. Our incredible partners that we're working with here in India to transform the IT industry together. And so I'm delighted that all of you have joined us today. There are two fundamental shifts that are happening at the same time. In 1964, the IBM System 360 introduced the world to the concept of IT, the IT industry as we know it, introduced the idea of general purpose computing. For the last 30 years, we've had the benefit of Moore's Law, an incredible phenomenon. Without changing the software, the hardware can continue to improve in an architecturally compatible way. And the benefits of that software doubles every year. Moore's Law made it possible for us to continue to drive down cost, democratizing computing as we know it today. But we know now that the scaling of CPUs has reached its limit. We can't continue to ride that curve, that free ride. The free ride of Moore's Law has ended. We have to now do something different. We started our company to accelerate software. Our vision was there are applications that would benefit from acceleration if we augmented general purpose computing. We take the workload that is very compute intensive and we offload it and we accelerate it using a model we call CUDA, a programming model that we invented called CUDA that made it possible for us to accelerate applications tremendously. Real-time computer graphics was made possible because of Nvidia coming into the world and make possible this new processor we call GPUs. The GPU was really the first accelerated computing architecture running CUDA, running computer graphics, a perfect example. We democratized computer graphics as we know it. 3D graphics is now literally everywhere. And so over the last 30 years, we've been on a journey to accelerate one domain of application after another. Today, we accelerate so many important industries. Cullitho is fundamental to semiconductor manufacturing, computational lithography, simulation, computer-aided engineering, even 5G radios that we've recently announced partnerships with, that we can accelerate the 5G software stack, quantum computing, so that we can invent the future of computing with classical, quantum, hybrid computing. Parabricks, our gene sequencing software stack. QVS, one of the most important things every single company is working on, is going from databases to knowledge bases so that we can create AI databases. Using QVS, we can create and vectorize all of your data. These acceleration libraries now cover so many different domains that it appears that accelerated computing is used everywhere. But that's simply because we've applied this architecture, one domain after another domain, that we've covered just about every single industry. Now, accelerated computing, or CUDA, has reached the tipping point. Every single time I've come to India, I've had the benefit of talking to you about deep learning, had the benefit of talking to you about machine learning, and I think it's very, very clear now the world has completely changed. The first thing that happened, of course, is how we do software. Our industry is underpinned by the method by which software is done, the computer model that we understood quite well. And it, of course, created one of the largest industries in the world, right here in India, the production of software. Coding, programming became a whole industry. However, that approach of developing software has been disrupted. It is now not coding, but machine learning. This way of doing software, notice, is based on fundamentally machine learning. And we have gone from coding to machine learning, from developing software to creating artificial intelligence, and from software that prefers to run on CPUs to now neural networks that runs best on GPUs. This, at its core, is what happened to our industry in the last 10 years. We dedicated ourselves to advance this field. And so this is what we now build. This is what a GPU looks like today. This is Blackwell. Incredible system that is designed to study data at an enormous scale. We have now learned the meaning of so many different types of data. We have learned to represent, how to represent information in so many different modalities. Not only have we learned the meaning of it, we can translate it to another modality. So one great example, of course, is translating English to Hindi. Translating English, large body of text, into other English, summarization. From pixels to image recognition. From words to pixels, image generation. From images, videos, to words, captioning. From words to proteins used for drug discovery. From words to chemicals, discovering new compounds. From amino acids to proteins, understanding the structure of proteins. In the last couple, 2-3 years, the number of generative AI companies around the world, tens of thousands, tens of billions of dollars have been invested in this field, all because of this one instrument that made it possible for us to study data at enormous scales. In order to build the Blackwell system, of course, the Blackwell GPU is involved, but it takes 7 other chips. TSMC manufacture all of these chips, and they're just doing an extraordinary job ramping the Blackwell system. This is Blackwell is in full production, and we're expecting to deliver in volume production in Q4. This is NVLink, and it goes across the entire back spine of a rack of GPUs. And these GPUs are all connected from the top to the bottom using NVLink, driving these incredible SerDes, the world's longest driving SerDes for copper. And it connects all of these GPUs together. 72 dual GPU packages of Blackwell, 144 GPUs connected together, so it's one giant GPU. This is connected to this switch. And this is one of the most advanced switches the world's ever built. Now, all of this together represents Blackwell, and then it runs the software that's on top. This is what Nvidia builds today. Those of you who have known us for a very long time, it's really quite surprising how the company has transformed. But literally, we reasoned from first principles how computing was going to be done in the future, and this is Blackwell. And what we're trying to do is to learn larger and smarter models. It's called the scaling law. The scaling law comes from the fact that the observation that, the empirical observation and measurements that suggests the more data you have to train a large language model with, and therefore the correspondingly large model size, the more information you want to learn from, the larger the model has to be, or the larger model you would like to train, the more data you need to have. The second thing that we've discovered recently, and this is a very big deal, after you're done training the model, you give it a prompt, and the AI processes through a very large neural network and produces a sequence of answers. In the future, and starting with Strawberry, we realize that, of course, intelligence is not just one shot, but intelligence requires thinking. And thinking is reasoning, and maybe you're doing path planning, and maybe you're doing some simulations in your mind. You're reflecting on your own answers. And so as a result, thinking results in higher quality answers. And we've now discovered a second scaling law. And this is a scaling law at a time of inference. The longer you think, the higher quality answer you can produce. And so that's where thinking, reasoning, planning comes in. And the more you compute, the higher quality answer you could provide. And so we now have two fundamental scaling laws that is driving our technology development. First for training, and now for inference. The number of foundation model makers has more than doubled since the beginning of Hopper. There are more companies that realize that fundamental intelligence is vital to their company and that they have to build foundation model technology. And second, the size of the models have increased by 20, 30, 40x the amount of computation necessary to train these models because of the size of the models, but also multimodality capability, reinforcement learning capability, synthetic data generation capability. The amount of data that we use to train these models has really grown tremendously. That's one, and then the other reason, of course, is that Blackwell is also used for generating tokens at incredible speeds. And so together, all of these factors has led to the demand for Blackwell being incredibly high. Okay, so Nvidia in India. We have a really rich ecosystem here. The first thing that you have to realize is that in order to build an AI ecosystem in any industry or in any country, you have to start first with the ecosystem of the infrastructure. And we announced that Yotta, that ETE, Tata Communications, and our other partners are joining us to build fundamental computing infrastructure here in India. And in just 1 year's time, by the end of this year, we will have nearly 20 times more compute here in India than just a little over a year ago. That's the amount of infrastructure we're getting. Yep. So the first part of building an AI ecosystem is the AI infrastructure, just as the first part of infrastructure for the internet ecosystem was building the infrastructure of networking. Of course, the infrastructure of networking internet consists of the personal computer, cloud, and internet itself. In the case of AI, it starts with the AI computing infrastructure. The next part, the operating system of AI is large language models, and we've worked with partners here in India to build the Hindi large language model. And the next layer is the application layer above that. And working with us to bring AI to the ecosystem of India, of course, AI native companies that are creating new applications that are started, that are made possible only with AI. And then our service partners from Wipro to Infosys to TCS, working with us to take the AI models and the AI infrastructure out to the world's enterprises. Now, that's NVIDIA in India. I'm going to have Vishal, our country leader, come join me on stage. This is a time now where the large language models and the fundamental AI capabilities have reached a level of capabilities we're able to now create what is called agents. Large language models that understand the data that, of course, is being presented. It could be streaming data, it could be video data, language model data, it could be data of all kinds. The first stage is perception. The second is reasoning about, given its observations, what is the mission and what is the task it has to perform. In order to perform that task, the agent would break down that task into steps of other tasks. And it would reason about what it would take, and it would connect with other AI models. And so we're going to have agents that are helping our employees become super employees. These agents, or agentic AI models, augment all of our employees to supercharge them, make them more productive. That entire process we put into essentially an agent lifecycle suite of libraries, and we call that NeMo. Our partners are working with us to integrate these libraries into their platforms so that they could enable agents to be created, onboarded, deployed, improved into a life cycle of agents. Essentially, this is a factory that builds AIs.
Today, we have computing from Yotta, which has built the state-of-the-art infrastructure. Tatas are going live. E2E has been in existence, giving us accelerated computing infrastructure for a long, long period of time. All this computing helped us to leapfrog to solve one of India's largest problems. That is about communication. Today, the work that we are doing in IITs, the work that we are doing at different organizations is all a result of coming together, solving the critical issue that India has. Not only was the language getting solved, we also realized very quickly that there are many mega challenges that India has. A well-spoken Indian and a healthy Indian always make a difference, and that's why we have companies who've been working on health. As many of us know, it's been challenging. How do we look after our health? But diagnostics coming from SickTuple, Cure.ai is really helping us solve many of these challenges.
It takes an entire ecosystem of partners to be able to help the world apply AI to help their employees be more productive. And this is whereas India was focused on IT, the back office, operations of software, the delivery of software, producing software. The next generation of IT is going to be about producing and delivery of AI. And as you know, the delivery of software, coding, and the delivery of AI is fundamentally different, but dramatically more impactful, insanely more exciting. And the ability for this industry, for India, to help every single company around the world to enjoy the benefit of agents, to enjoy the benefits of AIs across all of their different functionalities, to be able to deploy it at scale, that next generation of AI needs to understand the physical world. We call it physical AI. Now here in India, we've got a really great ecosystem who is working with us to take this infrastructure, take this ecosystem of capabilities to help the world build physical AI systems.
And you know what I've really loved is Adverb is one of the largest robotics company. They build robotics, and more importantly, they put it in a digital twin where optimization takes place. They teach the robo all the inputs that comes out of the physical world. Not only is that work taking place, our system integrators, Accenture, TCS, Tech Mahindra, are taking that knowledge not only into India, but also outside India. So do it in India, for India, and do from India for globe.
Start locally, grow globally.
Right.
Right, that's fantastic. I want to introduce you to somebody I met today. There's a superstar in the audience. Akshay Kumar.
What I want to know is, what is one thing which AI can't copy from humans?
Depending on the jobs that we do, sometimes it could do 20% of our jobs, 20% of our work, 1,000 times better. For some people, it might be able to do 50% of their job, 1,000 times better. But in no job can they do all of it. Every one of us should apply AI to automate, to become an assistant to help us with that either 20%, 40%, or 50%. And so the most important thing for us right now is to build amazing AIs, build safe AIs. That's good engineering discipline, good engineering business, good engineering process, methodologies, technologies, all come together so that we can build safe AIs. It's like building a safe airplane. The automation systems with diversity and redundancy, all of the backup systems makes it possible for air travel, the airplane to be safe, and air travel to be safe. The same ideas will apply to artificial intelligence. Right. It is our fundamental mission to enable AI to be realized for the benefits of society, but doing it in a way that is systematically safe. And not only do we make the AI safe, we create other AIs to keep it safe. I have another special guest, an industry pioneer. Someone we can genuinely say digitalize India and help build the fabric of the modern internet India that we know. Ladies and gentlemen, Mukesh Ambani. The IT industry of India is world-renowned for its very large scale and not just in size, but in deep expertise of computer science. Very few countries in the world has this natural resource, this amazing natural resource called IT and computer science expertise. In the last couple of years, we've been working together to upskill, and we've now upskilled about 200,000 IT professionals into the world of AI.
India has become home, right? Among all the companies across the world, our fastest growing industry is global competency centers. So we do space research in India, we do pharmaceutical research in India. I'm sure that you're thinking of building chips in India.
That's right.
We are in our own energy industry, we do bioenergy industry. All the energy majors, Shell, BP, right, actually do their innovation in India. So India is fast becoming an innovation hub for the world in terms of where we are today, apart from the US and China. Right? India has the best digital connectivity infrastructure, 4G, 5G, and broadband in the world.
Yeah. One of the things that you've highlighted is just the immense amount of digital data that's available, surely at Geo and in India. And this leads to one of the things that I want to announce with you. As you know, in order to lead in artificial intelligence, you need to have AI model technology that India has. You need to have data, massive quantities of data. The last thing you need is AI infrastructure. And we're announcing that Reliance and Nvidia are partnering to build AI infrastructure here in India. So now you have the fundamental ingredients, AI, data, and AI infrastructure, and you have a large population of users that ultimately creates your AI flywheel.
We are now ready for big scale up. So we are building infrastructure, right? And we think big, so we're building infrastructure for 1 gigawatt, which can be expandable to multiple gigawatts at one location. It is important that we design and build infrastructure so that to use AI, our customers don't have to change a phone, don't have to change their computers, but they can still get good quality AI, and we take the burden of putting that infrastructure together.
Yeah.
And I think that is what we are counting on you and us to do. The foundry tools that we have, we are looking forward to a development center where we take core of your tools and train hundreds of thousands of developers in India to use all the enterprise tools, to use the Omniverse tools, so that we can really apply intelligence in a practical way. And to me, this is just the starting of this intelligence age.
Certainly, we would agree that this is an extraordinary time for the world. And this is an extraordinary opportunity for India to have precisely the conditions, to have such a large population and large industry of computer scientists at a time when this industry, the computing industry, is going to become the intelligence industry. Leveraging on everything that you have, leveraging on everything that you know, and your indigenous advantage, enormous amounts of data, a large population of consumers to drive that flywheel of intelligence to data, data to intelligence, intelligence to data, and have the national will to go do something about it. This is such an extraordinary time, and I am honored and privileged to be partnered with you to do this. And let's make it a promise today that we will work together so that India could take advantage of the intelligence revolution that's ahead of us.